Hello, everybody. I always wanted to jump on a stage like this. Never been before. Yes, this part is full, this part is empty. So let's hope a few people come. So I'm going to talk about, give you insights into SAP's infrastructure, running OpenStack on Kubernetes. It was a theme the whole day, theoretical possibilities, and could we do it, and should we do it, and what's the pros and cons. I think hopefully my presentation gives some confidence about why it's a good thing and it actually works. It's also some code sharing in the end. Everything's open source we do to get some real examples to see if you can replicate in your own data centers. So before we get going, SAP is not such a common name like Google. So a few words. SAP is the world leader in enterprise applications. Founded in 1972, so we're application dinosaurs. There's a lot of old code bases, so not everything hipster cloud native. Our vision is to help the world run better, and our current innovation focuses is cloud and memory computing, Internet of Things, and digital business. We're in a transformation from a classical on-premise application to a major cloud business, which comes with its own challenges. So SAP customers produce around 78% of the world's food and 82% of the world's medical devices, and around 76% of the world's transactional revenue touches an SAP system. More or less nearly everywhere when business transactions are made, some SAP company is involved. We have over 310,000 customers in 190 countries, a lot of employees, around 50,000, 50% of 78 are technology related, and especially in the cloud business, we have 110 million users. It's quite significant. About myself, I'm Markus Riedinger. I've been heading the web unit in SAP, developing identity systems, document management system, classical websites, stores, traditionally between 2005 and 2013. And our unit was starting to implement continuous delivery, and well, the related DevOps movement was on. And we were starting to build an infrastructure cloud for SAP that was able to handle those use cases on top. And 2013 plus, we started to rethink and switch to OpenStack, and that's when my unit moved to the cloud platform and products. And what you're seeing today is actually what happens when you give web developers the task to build an infrastructure cloud. So none of my team members is operator or infrastructure expert. We learn top down and not bottom up. And potentially that's the result. So SAP on OpenStack. Short slide about key challenges we had to overcome, which are potentially quite similar in all traditional enterprises, then move from on-premise to a more cloud-oriented business. One slide about our global distribution of the infrastructure we build and the key set of features that differentiate our OpenStack from a mainstream deployment. So SAP, traditionally known as the R3 company, with various names starting from then, but we have various acquisitions on the way. Concur, Ariba, SuccessFactors, the three big ones to name. So we're running variations now of cloud-native built applications and on-premise style applications. On-premise testing, development, but also on-premise cloudification, hosting. And all those solutions, they don't run on a common used infrastructure as a service stack. It's around 23 mainstream, the bigger stacks to count. They're all system integrated built from the storage device upwards, custom for that one solution. So we end up with enterprise virtualization and cloud native application as a key jingle, and we need to support both in our stack. Since some software has its origin in 1972, you cannot do everything in Docker containers, obviously. We have an additional complexity and a differentiator. We have, with SAP HANA, an in-memory compute platform that uses heavily a performant bare metal stack down to optimizations on memory and CPU types and whatever. Our key challenges, though, is that operations is stretched to its fundamental already. So we're growing some businesses 100% per year in the cloud, but the operations is founded in the classical IT organization, ITEL-based organizations, and they're stretched like hell to even accommodate the existing data center build-outs. So we have the pattern of linear growth between staff and the growth in equipment. So meeting quality and availability targets is a really, really big challenge. It comes with the process overhead and the people hiring, and it actually shouldn't. So what we're building is a private infrastructure as a service optimized for SAP payloads powered by OpenStack. The key three features are KVM, VMware, and bare metal hosts, Nova host, join the same Neutron L2 network. For those who do OpenStack, know that this is not a simple thing to achieve. The second half of the year, we're going to add Kubernetes pods to be available in the same L2 network, primarily making sure that the company's development isn't dependent on a hypervisor or on a specific technology, but we invest in OpenStack, we lock our customers into the OpenStack contract, our internal stakeholders, and the development of the underlying compute infrastructure needs to have the full flexibility to evolve. That's why we have KVM, VMware, and bare metal, and Kubernetes pods later on in the same L2 network. A big amount of deployments of SAP solutions require a shared file system. So we have NFS as a service, also joining the same L2 networks as the Nova guests. And the bigger locations we deploy, they don't survive with only around 4K networks, which you normally get when you have a VLAN-based networking infrastructure. So we have the whole problem about overlay technologies and how do you extend the space. I think everyone who does networking in OpenStack knows exactly what I'm talking about. So it's around 13 regions and a minimum of 18 data centers spanning those regions. On the right-hand side, you see the services we deploy. I'm not going to go into detail. There's a few SAP-specific services we have built in-house, and the rest is like a few of the standard OpenStack services. To call out potentially is we deploy Swift at scale, Manila at scale, Designate at scale, and also Barbican as part of the load balancing as a service. So this is all nice, but it doesn't help at all in getting operations to have an easier job. Because we're adding on their stretched operations in OpenStack, and normally the situation gets worse. There's nothing that helps operations to do something easier than before. So all the problems persist except the manual ticketing to configure something on a load balancer. So you get efficiencies, but the stretched operations for downtimes, quality, build up new data centers is just made worse if you deploy a standard OpenStack in 13 regions. You have operations teams for that, and everyone who deploys that in various regions knows it's not a 5-person job to do. And you can't do it with the classical outsourcing approach with managed service. It's also going to fail, at least on the scale we do. So we had to come up with something a bit more clever than just deploying OpenStack with some Puppet or Chef recipes. And that's what we've done. So Giphy and hierarchical port binding to the rescue. So Google infrastructure for everything else. I'll come to that later for those who don't know. And Neutron hierarchical port binding is our way to do networking with enterprise gear. I'll come to that later. So there are 3 fundamental concepts of our OpenStack cloud. It's a very, very clean mandatory separation of control and data, a full automatic system with embedded analytics using Kubernetes and CoreOS to run OpenStack and its accompanying supervision. The idea of a full automatic system with self-healing where operations doesn't have to operate that cluster, they have to operate the service. Like if customers have a support question, I can't boot a VM to figure out if they have chosen the wrong subnet or something. But the rest of the operation should be minimized to nothing. And the third component is the bare metal part, is like to go with pre-manufactured pods for a capacity extension. They consist of switches, compute nodes, and storage, pre-manufactured by a set of vendors, brought into all locations, the racks put in, cabled on, and that's all to be done. Good, so the general approach, pre-manufactured pods. So we extend each of those pods in one unit. Most of the time they have 16 compute units of 2 terabyte RAM. And that's what the talk is not about. There could be a separate talk for 2 hours just about that topic. And the second is like to clearly separate control and data, which allows an independent service level objective for the data path compared to the control, which also implements independent processes and procedures to scale each of the aspects, the control and the data separately. leading to extending and fixing and improving the existing model to operate the vendor gear. So SAP is quite a classical organization. So we buy EMC, NetApp, Cisco, blah, blah, blah. No self-developed hardware like the cool kids do. And the existing operating model should be persisted and just fixed and extended to not overload them with like a complexity of Nova, Neutron, KVM deployment with Open vSwitch. They're going to freak out. And on top, provide the control via an automatic self-healing, self-supervising, immutable system. OpenStack on Kubernetes. So, the core of it, containerized OpenStack on Kubernetes, for real. I'm going to have a demo later, a video, better say. So the control plane is containerized on Kubernetes, which allows us to do constant releases with low-touch operations, meaning operations maximum authorizes the release by pressing a button. And that's even under discussion at the moment, if they have to do this. OS patching is via CoreOS auto-update. So no one's touching the operating system. It's auto-updating what CoreOS provides us. And the cluster accommodates the fact that the hosts will restart at a given point in time just because they get an update. Automatic self-healing, consistent and immutable. System I said already. This leads us to no downtime in the data path. When I say no downtime, the number of nines are currently under discussion, but we're aiming for a no planned downtime of the data path, which traditional vendor gear, switches, storage boxes can provide you. That's quite old business. And limited to no downtime in the API. So currently we have a few seconds downtime for some of the API deployments. And obviously when we go from Mitaka to Newton, it may be a bit longer than this. But the payloads in the data path are not affected, so the API won't be available for a time. It's a quite important thing. We can't take a data center offline just to upgrade OpenStack. And that's still happening too often, I think, when you try to go from Kilo to something. You bring all your payloads down and upgrade. That's no good. So effectively, it scales linearly across 13 regions. So if we've done it once, we do it several times. Because we have everything we do is bootstrapped from bare metal automatically. No one touches the systems, anything, after the cables have been put into the infrastructure. So effectively, 1 to 2 people can take a data center from commissioned bare metal to an operational, scalable Kubernetes cluster running a fully configured OpenStack platform in less than a day. All subsequent patches and configuration is automated via continuous delivery pipelines. So as I said, initial boot of the infrastructure once it's cabled, a few persons, a few commands, and after that, no one's going to the data center to do any software upgrade or anything like that. There is no pets, there's only kettle. So the demo I'm going to have takes 5 minutes. It's a video. It doesn't fit otherwise in the 20 minutes. It shows a full installation of the system I just described. We boot the host, a guest OS. We SSH into the guest OS, ping outwards, and demonstrate killing all Neutron pods and let the system self-heal. And you see like the time self-healing takes and everything like this. So back office support, can you please start the video? So we're going to do bare metal to running OpenStack in 90 seconds. We'll see. And first, we generate the config. So we're using CoreOS boot CFG, a boot CFG server to bring up the CoreOS nodes and also to orchestrate the configuration of it. It's a Concourse pipeline that's building that central service. The input files are YAML. We're doing those manually from the MAC addresses and everything the infrastructure team has provided us. Then we install Kubernetes, also through a pipeline. And that's also how subsequent upgrades and everything of Kubernetes is working. There's a classical iPXE. With the OpenStack, with the CoreOS Ignition, we use heavily. And after the end-to-end tests are through, which obviously takes 5 minutes itself, we have a Kubernetes cluster running. For everyone who knows Kubernetes, that's the normal dashboard. And shows the Kubernetes nodes and the pods running. So the same view from the command line. That's our staging system. So in production, it's 3 times the nodes. And it shows all pods required to run Kubernetes itself. Now let's install OpenStack. It's currently like a simple bash script to have some sequencing in the installation. But actually, it's just deploying the pods using the Kubernetes specs. And you see most of the services here. So that's our custom dashboard we deploy for all our regions. And we boot up a server. Ramping up to the key of the demo. So just a normal zeros like everyone does, nothing special. In this case, it was selected VMware in the VMDK format. An elastic IP to actually ping it. And the ones who know Google Cloud Engine, we have something similar. So the full extent of the API of OpenStack is available through a web CLI. So the UI, will take some time to develop in the full-fledged feature set. So we SSH into that zeros machine, so the data path in, and we ping from the machine out to sap.com. And we see that in a split screen running on top all the time for the next steps. So we grab all the Neutron nodes. You see them running in the middle. Our health dashboards for the API endpoint using Grafana, Prometheus, and Monasca. And we do something stupid. More or less, we emulate a full disaster case of deleting all Neutron nodes from the system. So they've been deleted. They're recreating now. On the right-hand side, you see the seconds it takes to come up. So they quickly run into an error because the Neutron server is missing. We see an API downtime in our dashboards. And when we wait a bit, the Neutron server takes the longest. And you see on top, the ping going out is working all the time. So we have the data path is still up, no effect. Even though we shut down Neutron completely, the system keeps operations for the customer. Just the API for Neutron has been down for a tick. So everyone who operates an OpenStack, not like this, would know what happens if someone accidentally throws away the 2 Neutron nodes. You have an all hands on deck in the company, and not like this. And this is actually running in production. It's not a fake demo or anything. Since July 1st in our first region, and we're rolling this out worldwide now during the rest of the year. Oh. Actually, that should go to the next slide. Thank you. So 2 concepts I want you to take away from this, which make our cloud like it is. The first one is hierarchical port binding in Neutron, and the second is that you dare to run OpenStack on Kubernetes. It's ready, it can be done, it's just some work. But if you write your own Puppet modules or Chef modules, it isn't much different to this. You just need to dare to do it. So hierarchical port binding, again in summary, allows you neutron networking with more than 4K networks if your switch vendor supports an overlay between the spine and the TORs. It allows you to deploy this without an additional SDN solution in between, which will drive your traditional operations at least nuts if you do this. And the speciality is it doesn't require to deploy proprietary or anything like drivers on the hypervisors or the bare metal hosts. It works with VLAN devices, which every vendor supports. So you have no vendor lock-in. So the networking stack doesn't bleed into all the hypervisors and everything. And you're able to run in a clean separation between control and data, allowing you to manage your OpenStack like a website. It's down, who cares if the API is down for 20 minutes, right? As long as your data path is up. SAP is working with all major vendors, the most major vendors were from the traditional space to enable that feature. For networking, it's Cisco and Arista. With storage, NetApp and EMC, specifically for Manila, and VMware and KVM for the hypervisors. We have OpenStack on Kubernetes, and the summary is like it reduces the operations effort, significantly lowers the time to resolution, as you've seen with the Neutron down. In some good cases, you don't have to do anything. And it enables to continuously deliver your OpenStack, upgrade your OpenStack, since it's decoupled from the data path. So a neutron upgrade for us is not like a major undertaking where we can't sleep at night. It's definitely going to work. If we are an hour down, it's no board escalation. It's just some maintenance of an hour potentially. If we're lucky, it's going to be 5 minutes. Since the upstream of this OpenStack on Kubernetes isn't simple at the moment, there is Collar Kubernetes we have tried to kick off, which is going so la la. And we have Stack and Netis driven by Cores. We're trying to do our best to bring those communities together, to have a container build and a reference spec suite for Kubernetes. Until then, we are providing all the source code of what we do on our GitHub repo. This is not for productive use. It's not not a distro or anything like this. It's just to facilitate the discussion in the community and the best practices we use. There's also Prometheus and Monasca integrations and middlewares for OpenStack for monitoring and stuff like that. So I encourage you to look at it. And with this, I'm finished with my presentation. Thank you. I think I have some spare time left even. Don't hesitate to contact me. I'm always open to questions. I'm also here tomorrow to handle more questions. Thank you. Do we have time for questions?
10 o'clock says you have 5 minutes.
I do or do not? Okay, one. Anyone has a question?
Actually, just used up your question.
Okay, good. Thank you. So I'm free for questions in the hall. Thank you.